All right, all systems are go. Hi friends, I'm Andrew. This is Code Gets Creative, where we do all sorts of creative coding and fun projects with code. Yeah, welcome. It's good to have you back. Let's talk about what we did last week and then what we're going to do today. Last week we put one of these guys together. So this is a Eurorack synth module. Let me turn my sound down a little bit on my end so I can think. Yeah, so we put the synth module together. It came from a DIY kit. We soldered all these parts together, put it together, tested it out in the Lunchbox synth, and we were able to get mega oscillators going, where basically we had like two different oscillator sounds going at the same time in this big synth box up here. Yeah, it turned out great. Everything's working. I need to block out some time to like rearrange a couple things in here so that I can get this fit in like where it is gonna work best. But yeah, for now I'm very excited about this. It's gonna be very helpful. Put that down. And I mean, we've done some other like hardware stuff in the past as well. Here's like a little Raspberry Pi 4. You remember that we got the Lightblocks program running on this. So we were able to control Philips Hue lights from a web app that we could navigate to running on here. So that's great. Today is not all about hardware though. Today is about software. And we're going to be doing generative art. And I think it might be cool to kind of talk about one of my favorite pieces of generative art in history. I'll show you how I recreated it the other day. And then I think we can get into like writing some new generative art. I've got some ideas that I think will be fun. They are kind of music and synth related. So that'll give us some inspiration to start from. So let me show you this cool print that I have. Oh yeah. So this piece, oh hey, you can see my windows through the reflection. Maybe I'll hold it kind of diagonal-ish. But this print is of a piece of computer art from 1965, I believe, by a computer scientist named George Nies, and it's called Schotter, which is German for gravel stones. So kind of cool. I'm gonna stop holding this. This is kind of silly that I'm like trying to do this. Anyway, it's one of my favorite pieces of generative art. It is just so iconic. Let me put it down and then we can talk more about it. Let's see. Just set that. Oh, that over here. That back down. Cool. Okay, so yes, I have a print of it. I'm excited about it. My plan is to get it framed right here on the wall to my left, so I can see it all the time, and it's like next to my synth. It's an inspiration. Yeah. So let me actually. Let's see. I'll switch over to here. We're gonna talk about this in just a minute, but here's the original piece. Here it is on Arts Nova, I guess. Yeah, here's the original piece. Somebody has gone and recreated it. Oh, neat, and it like describes how to do it. Yeah, so this is all dedicated to like the generative art piece. Let's see. Yeah, February 1965. So, the reason I love this piece, if I like, why is this not zooming out? Got some weird JavaScript going on. Okay, so I mean, it's kind of fuzzy. It's not the highest quality JPEG you'll ever see. The thing that I really love about this is the system that was used to create this piece of art is like really easy to see visually. That's basically that you've got a bunch of squares that all line up in a grid, right? And so you're iterating top to bottom for rows and then left to right for columns. And you've got each of these squares. But as you go down each row, it gets more and more chaotic, right? And it gets chaotic in two different ways. The squares are displaced, meaning like they have an offset. They get moved left or right or up and down. They're translated to some new position. But their rotation also begins to get more and more chaotic, where they start out just simply vertical, and then they begin to like rotate around more and more and more as you go down. Row number 1 is like very, very calm, very simple, right? You start to go down a little bit more. You can start to see these kind of like cracks in between the cells where like things are overlapping strangely now, more and more and more. And now it starts to become really obvious that like rotation is also happening. You can see some of that. You can see these like kind of like drifty sorts of lines emerge instead of this like pretty much straight line towards the top. So that starts to get more chaotic. And then as you get further, like the lines even fall apart. Like there's not even a very super clear row anymore. That begins to break up, and by the bottom, it's pure chaos. Everything's bouncing around. It's a lot of fun. Things are going everywhere. And yeah, once again, like I really like that idea that you can look at this piece, you can understand the system that went into it, but it's still like very fun visually. It's like interesting, kind of emotionally. I don't know. We can get philosophical, but I think sometimes we feel like we come up with nice orderly plans, and when we start to put them into practice, they get a little crazy. Maybe they don't turn out according to plan. Maybe we start our our exercise routine and we're doing really well, and then as time goes on, it turns into a mess, whatever. But anyway, I really love this piece. I think it's awesome. Let me run over to here next. So this is p5js.org. Maybe we should also go over to here to processing. Processing is it's like a framework. It's a sketchbook for creating art with code. We got some like cool stuff going on here. Teaches you how to get started coding. It's great for beginners because it's very like gratifying and like visual when we see changes happen to our code. But really, it's not just for beginners. Like you can use this once you're well into your kind of career or well into your like journey programming. It's a great way to create art with code. And so there is a dialect of processing called p5js. You'll notice it's linked right here. And so it's an implementation in the JavaScript language. And that's extra awesome because it runs right in the browser. So I don't need to like download anything. I don't need to compile anything locally on my computer. I can just like click right here, go into the editor, start typing in code. You can log in with Google or log in with GitHub, and it'll just like save your sketches, they're called, your little mini programs that create art. It'll just save all those on a user profile for you, and you can come back to them later. And so it's just so it's such a low barrier to entry, relatively speaking. It's really nice. It also has good documentation. So let's see. I believe there are actually some cool like tutorials. Yeah, learn. I think it's in here. This will kind of walk you through how some stuff works. I think it's. I maybe wouldn't start here if I was like a brand new beginning programmer. That it would probably take a little bit more hand-holding to understand like what's a function, what's a variable, that kind of stuff. But I think this is a really good like early sort of thing. And let's see, there's a reference over here where all of the functions that p5js makes available, we can go and use them here. So that's nifty. We'll be spending some time in here, and we'll be spending some time in the editor. So let's jump over to here. Here I have kind of recreated the George Nice Schotter or gravel piece. I ended up naming mine Pebbles, whatever. I was thinking of doing something a little different, and then I was like, you know, I should just recreate it because it's really fun. But check this out. Every time I click this play button, it's going to run my code again, and this piece is going to come out looking a little bit different from before. So boom, boom, boom. Right, every time is a little bit different. Now, in terms of like the layout, it's still very similar. This is still like the same amount of uniform, and this is the same amount of chaos. And that actually has to do with like the variables and the logic that are down in here. So let's like check that out. Quick code review. So we've got some constants up here. We'll talk about them later. We've got two functions. These are like the building blocks of every P5 sketch. So notice how we have a function called setup and a function called draw. So setup is logic that you should do at the very beginning when you need to like choose how big your canvas is and sort of like details about, is your sketch going to be animated or not? So no loop says don't run draw over and over and over again, just run it one time. And then I chose to put this here. This basically means like create rectangles from their center rather than from like their top left corner. So that's that. Cool. So then we draw. This is the part where we actually like render things onto the screen. So notice how we say background. We pick this hex code to like choose background color, and notice how it's 600 pixels wide by 700 pixels tall. That's from this code right here. There's no fill, meaning each of these squares, each of these rectangles that happen to be squares, whatever, you see this rect right here, short for rectangle. Each of these is not filled in with some color, they're transparent. But they do have stroke, meaning like we're drawing lines on the borders of them. And the weight of each of those is 1.1 pixels thick. That's what that's about. Okay, then we've got some logic here. Notice how there is a for loop with a for loop inside of it, and then some other logic. So we basically say create some rows, right? Start with row number 0, keep going until you hit the number of rows. So there's our first constant up here, 15 rows. Right, and then same thing with columns. So we're gonna, we've got this outer loop that's going from top to bottom. We've got this inner loop that's going from left to right. And so every time we get to the inside of these curly braces, we have a new value for the variables row and col. And so we need to calculate the center x, cx, and the center y, cy. And we're going to do that based on these calculations. You basically say like, take the column number times the item width. So notice how each of these items, each of the pebbles, is 30 pixels wide. And then we also add this padding x, which is basically like shift everything over by this much. Right, it's that thing. There's also a padding y that we see for cy. Cool, so we figure out like the center x, center y, and then we pass that into draw item. So we've got our own function. This is not part of P5. I wrote this to make it more clear what it's doing. But notice how every item has a cx, a cy, and a row index. And then based on that, we're going to randomize it a little bit based on how far down we've moved. So notice how the max random offset, meaning like how far are we allowed to move up and down, left and right, that's going to be based on the row index times this number. That should be a constant. I should move that up there. Let's do it now. Let's see, random offset. Is it a coefficient? Yeah, I think it is. Well, I don't know. We'll just say like mult. We're not gonna get too smart alecky here. So we'll put that there, and then we also need a random rotation. There we go. And we'll put that here. Rerun that, sweet. So everything, you know, it behaves the same way still. So we know this is our maximum for each of those. Then we say, all right, well, let's pick a new center X and center Y. And that's based on this. So we say pick a random number between 0 and that maximum. And then we're going to shift it back down, right? Because we need to average it out so that 0 is the center. It could go a little bit above, a little bit below. Same thing with, oh, sorry, a little bit to the left, a little bit to the right. Same thing with up and down. So that's that. Then random rotation is kind of the same idea, right? Very similar logic, just different variables. And then what we do is we say push and pop. What that means in particular is these two commands, translate and rotate, get added to a state that we push that state onto a stack and then we can pop it off later. Basically what that means is, hey, we're gonna draw a rectangle and I'm gonna pretend that it's centered at 0, 0, which is up here, right? It's the very top left corner of the screen, of the canvas. But instead actually translate it down, like move this far over to the left, move this far, or move this far along the x-axis, move this far along the y-axis. And so that way, it makes it really easy to calculate that. And rotate really helps because then I can just call, draw a rectangle rather than like draw a polygon of 4 points that I have to like calculate individually. So it like simplifies things for us. So that's what that's all about. We draw the rectangle, and it is a square, right? So it's the same dimensions along x and y. So this is width and height, which is equal to width. And then we pop that off so that the next time we come back to draw, we're ready to translate and rotate by different numbers. Cool, so we talked about it all. We can click this some more. We can start making other changes if we want to. So, for example, let's say we want it to like offset more based on the row. We will change it just a bit for now. But you can see how it's more disorderly at the bottom now. We could go like really crazy. There, like some of these are even leaving like pretty big gaps in between rows because things are really getting jumbled up. So that's pretty cool. We could also change the rotation multiple. So I don't know, let's rotate by quite a bit more. That's so much that like it turns into chaos visually, like just a few rows down. So 0.5 is probably too much. 0.3. Starting to get better. 0.2 is like kind of I think you want it to be sort of this comfortable gradient between like normal or like orderly and disorderly, but like by the time you're just this far down, it's already kind of crazy. So I think I like that 0.1. We could go like 0.15. See, that looks pretty cool. I like that. Let's keep that new number. Good for us. Cool. So I have saved my sketch, and let me show you how that works. I can click open, and I've got a bunch of different stuff pulled up here, or different like sketches that I've saved. We actually did this one together back in May. That's cool. This is on the very first stream on this channel, actually, if you want to go back and watch that on YouTube. And that looks like this. The idea here is that this is a Eurorack blind panel, or blank panel, which basically means it is, switching back over here, it's just a faceplate, like just an aluminum or wood faceplate where a module would go, but instead of having jacks and knobs and buttons and everything that interfaces with actual electronics, it's just the faceplate. And so the idea is you can use that to protect your synthesizer so dust doesn't get in there and damage it, whatever. But you can have cool artwork on the front. So that's what that's all about. You can imagine like up in the top corners here, putting a screw here, so it can be held down into the rack. But you get this kind of cool like wispy effect, you know, of like patch cables that are crossing. So kind of cool. Very satisfying to just like click this over and over and be like, yeah, what have you got for me now? But this doesn't change like a whole lot, you know what I mean? Part of generative art is deciding like how chaotic is your system, or how uniform is your system. And like this one's pretty uniform in terms of like what it produces. So we could look at like having a system where maybe you get more aggressive or less aggressive about how much you shuffle. That might be interesting. Or what's the actual approach for shuffling? I think right now we're calling a shuffle function, which is built into P5, I believe. Yeah, here it is. So that's just like uniform random. You could imagine doing like a bubble sort, or like a random bubble sort, where it's like maybe switch these two or not. So that could be kind of cool. Anyway, yeah, exciting stuff. I think we should start a new one from scratch though. So let's do that. If I click run, boom, here's my artwork. It is a gray square. Before we just start writing code, let's do a little bit of design work in Excalidra. Let's see, so Excalidra.com is a very cool website. If you've never used it before, it's this sort of like scratch pad where you can draw shapes, you can do it collaboratively. It'll save your stuff for later. So you'll notice that I've got a lot of stuff here for light blocks. Here's where I did a prototype of the home page, prototype of the editor page, system diagram. Okay. I think I've got some other stuff. Yeah. Here's like that first prototype of that like Eurorack panel that we did. That's cool. Over here, we've got ideas for a generative animation project that I'm working on. I think we'll stream that later when it's in a little bit of a better place with its tree layout. It needs to get better before I'm willing to show that to the world. But yeah, let's start a new one. And I like, to be honest, I think this will be another cool like Eurorack panel design. So I would love to just start from this again. Maybe we even like move these side by side. So I'll keep this idea of the panel here. First idea doesn't include randomness at all, actually. It's much more like straightforward algorithmic. And the idea there, let's see if I can remember how to do this. Click to start multiple points, drag for single line, yeah. So what I want to do is, let's see that we got that. I want to do like a sine wave. And let's see. There we go. So I've got my sine wave. This has a period of 1, like per faceplate. You know, it starts here, 0 crossing, comes up, 0 crossing, comes down, comes back up, 0 crossing. And then we do another one, and let's see, we're gonna have to shrink this down. So we've got that, but then we do another one that is a period of 2. So it's basically this. And yeah, that'll work. So you can see, like, it's gonna be kind of lerpy. We're just doing like a quick and dirty kind of idea what this will be like. But it's now twice as fast, double the frequency, right? Now let's say that we want to do 3. So let's see. That's probably pretty close. Right here. That's close. We'll just resize this so it fits. Yeah, so you can see how it's going from simple to complex. I think these like straight horizontal lines are not as interesting, so I think we can tear those out. But it's, you know, it's getting more and more rapid and how it changes. So I want to just keep going more and more and more. It's going to get busier and busier and busier until we've got this like really crazy fast sine wave at the bottom. And that's the idea for that one. I think it should be cool. We could also probably experiment with like going simple to complex to simple. So like the middle waveform is the very fastest or highest frequency, and then the top and bottom are the same, and they're simpler and lower frequency. Yeah, so let's try coding that up. And I think this is a good chance to actually do some measurements on how Eurorack panels work, because I think we can write some reusable code here that when we make more ideas, we can just reuse that. Let's see, Eurorack HP 2 centimeters. Yeah, okay. So here's Mod Wiggler, which is the famous synth forum. Yeah, and I'm sure this is like not changed since 2013. It's a standard that's been around for a long time. 1 HP is this many millimeters. Oh, it's in terms of inches, isn't it? Gross. Okay. 1 HP is 5.08 millimeters. So let's say HP to CM equals 5.08, right? Yeah. Okay. The other thing that we need is the height of a module. I wonder if this actually mentions it. No. Let's see. Eurorack height 2 centimeters. Oh look, I've already been here. I did some design work on like a very minimal case where I needed to calculate some of the same stuff. Let's see, real sizes. Yes, I remember this in particular. I recreated this in Fusion 360. It was crazy. It was probably tip-top Z rails because that's the kind that I had at the time. Let's see. Why am I not seeing height? Maybe I scrolled past it. 3U 19 inches. Rack spec is that 5.28 inches. Let's see. Is the slot center to slot center dimension? Which is that. Okay, so that's that's like from the center of this hole to the center of this hole should be. I mean, part of me is like, let's just get out the digital calipers and just like pick a number that's close. Well, and I think like if this is all variables, it's easy to change later. So let's actually grab this for now, and we'll suppose that that's our canvas, and then we'll decrease it a little bit later. Grab that. And let's see, we're gonna say 3U to, yeah. maybe we'll just say like panel height cm. Oh, let's see, that's in millimeters. So that's centimeters. Right? 12 centimeters? Yeah. Sounds about right. So, let's say that we've got like panel width HP. And we're gonna make a, by the way, this is 4. This is what 4 looks like. I think we should choose 8. 8 is pretty common for manufacturers to build like blind panels to that. Cool. So let's see. So this is going to be, let's put it in this order. And let's see, we need to multiply this cm2px. So let's say that, because what is this really? It's like 5 centimeters times 8 is 40. That's no good. Actually, let's do it in terms of height. 12.25 times something equals a reasonable height. Let's aim for like 800 or so in height. 800 divided by 12 is 65. Yeah, so let's try that then. So we're saying 1 centimeter times 65 equals the number of pixels. That didn't produce what I thought it would be. I think I did my math wrong. Let's see. So this should be 5 times 8. I mean, 5 times 8 times 65. Yeah, that's thousands. Watch this. I'm a terrible person. I'm just gonna pick a number. And then the canvas height is going to be, what is this? Panel height, centimeter times centimeters to pixels. What? This is not looking right at all. Okay, so... Oh! This is not HP to centimeter, this is HP to millimeters. Right? Isn't that what where did that go? 5.08 millimeters. Yeah, okay, so we're... It's that. That is the right shape. Because that is, you know, more or less this, twice the width. So, okay, now I'll bet if we do this, it looks great. Okay, the world is making sense again. That is good. Okay. And let's actually come up a little more. Now it's off the page. 70? 80? Sure. We'll go with 80. Okay, so we know that this is our canvas, more or less. We can start drawing stuff in it. We need to draw some sine waves, and we can probably do this. I mean, we've got the sine function. I think it's, yeah, sin. So here's that. Notice how, by the way, this looks really cool. So this works with a for loop where you just pick a point horizontally and you draw a line, right? So that's cool. Angle mode? Oh yeah, angle mode is degrees or radians. Look at that thing go. That's great. Very effective. Okay. Let's see. There are Bezier curves and there's splines. Aren't there splines? Oh, maybe it's Bezier vertex. Let's see. This is why we love the reference. We can just scroll through it, have a look. I wonder if it might be this curve. Draw a curved line on the screen between 2 points, given as the middle 4 parameters. So if the curve came from this point, even though it's not the last 2 parameters. Is an implementation of Catmull ROM splines. Yes, this is what I want. By the way, shout out to Ed Catmull. Ed Catmull is really cool. He's the president of Pixar. Like, he's actually like in a bunch of the like literature and algorithms for like visual art with code. So yeah, we appreciate his work. Okay, so let's have a look how to do this. I think we can basically use this to approximate a sine wave. The reason we're going to do it this way is because we need to... Oh, is this the best way? I'm not sure anymore. The thing I'm thinking of is basically like we have to sample in these points. There's not really a way to, at least I think, I mean there probably is, to like define like the exact shape of the curve from here to here, halfway. Should we Google that? No, we're already like too deep in the weeds here. Let's draw a curve that's like basically a sine wave, and that way we get a focus on the art, and then we can come back later if we want. You'll notice that's kind of a theme, like err on the side of like doing a thing, you know, and then like you can always go back later, because generative art is all about iteration and trying stuff. So let's just do this. We're gonna make some vertexes. Let's see. Oh, 3D. Yes. So you begin a shape, draw a bunch of vertices, and the shape. Just do this. By the way, we want a no loop right here. So there's our tic-tac-toe. And let's see. We need to look at the we need to look at begin shape to figure out what goes in there. I think we want no fill and then nothing in here, because this is essentially what we want to do. No fill. Nah, looks like that now. So let's do, we'll draw a point like right on the edge there, and then over there. So say like from 0, 100. And then let's do, see, I don't know how wide that is. Let's see, let's make a variable of that. Max x, yeah. Oh, which is really just canvas width -1. I mean, really, it's supposed to be negligible. Like we're in. What I mean by that is, we're working in raster right now, where it's like a number of pixels. But if we were to actually print this out, we would do it at such a high resolution that it wouldn't really matter. And so we might as well say canvas width. So, and you know what? These need to be available to everybody. So we're actually gonna make them constants. So now, I don't need that after all. Let's do canvas width 100. And then let's do canvas width divided by 2, 150. Yeah, so you can see how I've gone right like that. That's cool. And really this is gonna be 100. And let's actually write it like this. This makes it more clear what our intent is. And let's say we want to go up, and let's see, you're looking the other direction from me. So we go up and then down and then back. So maybe we say 50 up here, and then we say 150 down here. Yeah. So what we have here is a triangle wave, not a sine wave, but we're getting in the right direction here, right? Cool, cool. And actually, if we wanted to, I mean, like, we talked about doing this in sine waves, we could do it in any wave, which might actually look super cool. Like, we could alternate or something between like sine waves and square waves and triangle waves and sawtooth waves and some other like weird complex wave. We could do all that. But let's start to pull this logic out so that we can reuse it. So I'm going to say draw wave, and let's say center Y, and then we need period is the term, right? Yeah, period, or cycles I think is a correct synonym for that. cycles. So we basically want to say draw wave where the center of y is 100, and I want 1 cycle in it. So then the center y is here and here. And then you can see a constant kind of emerging right here. But if we were, oh, we did something wrong. This should be a plus. There we go. Yeah, so let's maybe say, it's like a wave amplitude. And I want to do it in centimeters. And that should be, gosh, I don't know what that should be, because we're converting that to pixels. So we're doing 50 pixels right now divided by 80. If we go the other way, it's this many centimeters. So then over here, we've got amplitude pixels equals this times centimeters to pixels. And we get the same result. Good. But now it's super easy to tweak it, right? Like I can make it shallower, I can make it much shallower, I can make it, oh, wrong direction, I can make it like really tall. You know, so tall it goes off the screen, whatever, it starts to turn into Argyle when it's shaped like that. But yeah, that's something we can kind of tweak now. And I guess if we want to go crazy, that could even be randomized if we were working with randomness. Okay, cool. So, excuse me, now we need to figure out how do we adjust to a different number of cycles across the page, across the canvas. By the way, let's save this. We can call this like it's like waves. We should call it like wave folding. It's not quite folding. I don't know, waveforms. And it's a waveforms panel design. And eventually, I'm hoping that we end up with a bunch of different panel designs, and we can actually like create these with laser cutters or pen plotters or whatever we choose. It'll be sweet. Okay. So let's see, we need to draw another wave. I think that 100 number is not really defined yet. Maybe we should codify that a little bit. So what if we say like wave distance? And what is that right now? It's 100 divided by 80. 1.25. And then this is, yeah, that's equivalent. And I think at this point we can create a for loop. So we could say like num waves, right? How many waves do we want? Let's do like 8 for now. Okay. And then let's make this a variable. And that's going to be that, and then we'll draw that like that. Oh yeah, okay, so wave 0 goes off the screen. So we actually want to start, we're going to be 1 indexed rather than 0 indexed. Or probably realistically, we want to have like canvas padding. So let's maybe do that now. And what should that be? I don't know, probably like 0.5 or something. So that means that there should be like an offset y, which is this times centimeters to pixels. So it's all of this plus offset y, which looks like that, which means now we can be 0 indexed, and that like makes more, I think it makes more sense to have it that way. And in fact, I'm going to really lean into the idea that this is an index and not something else. So we'll call IDX. Okay. We need to increase that padding actually. So let's go like 0.75, something like that. That looks like that. Okay, cool. So that's coming together. Now let's figure out how to change this function when we've got a different number of cycles. So let's see. This part here basically needs to repeat, or like part of it needs to repeat. I need Excalidra for this. We're going to do these like very small bubbles. So we got one there. One there. One there. I don't really like how I'm like drawing over the top of that. Let's make a copy. We got each of those points, 5 of them, and if we were to do that again over here, the result would look like this. And like, I'm not gonna bother doing this on every single one, but we're like going to the next one. But you get the idea. So this is the point at which we repeat. Here, we'll color these blue. I think I use that shade. And so I guess we'd say that that is repeat as well. So starting vertex up, center down, starting vertex is also the ending vertex. So the loop is really these 1, 2, 3, 4 points, and then this is the final thing after we finish looping. Okay, sounds good. So let's see. This is our very final vertex right here. And we'll call this, I mean, it's, yeah, the cycle index. So there we go. That there. When we draw the wave, this needs to be idx plus 1. Now, yeah, we could have called this like cycles. I like the more abstract index though. The reason for that, I'm in didactic mode here, but like the reason for that is because if we're working in terms of an index, that's kind of abstract, and that helps us focus more on the idea that we are iterating. We're going to do the same thing over and over again. There's an index, and the index might mean multiple things, and in fact it does. We're going to derive a center y value in pixels based on our index, and we're also going to pick the number of cycles based on that index. And those two calculations are going to look totally different, right? Like this is this fancy equation here. This one is just add 1 to it. So that's the reason why I like just calling this idx for index. Okay, thanks. So let's see, we've got that. And so I think we need, let's see, we're tweening between different x values here is what we're doing. So notice how if cycles equals 1, then we're going from 0 to canvas width. As soon as cycles equals 2, we're saying go between 0 and canvas width divided by that number 2. And then start from divided by 2, go to the full value. So let's do this. We need to have a min x max x, and maybe here we'll actually, we're just going to refactor for a second here. So we're going to say min x is right here. And then this should be yeah, we need like a tween function essentially. So this is going to be tween between min x and max x 0%. Yeah. Okay. And so the way that we implement that is let's see, max minus min times percentage plus min. So let's see, if you think about that numerically, we're basically saying like start at a point, go to another point by some percentage. So we need to shift by that minimum amount. That's this part of the equation. And then we're going to say you want to go this distance by some percent. So it's this minus this times something. And that's how that works. So I think that should work. Okay, we switched this back to 1, so if I rerun this, we should see the exact same result. We broke it. Oh hey, here's why we broke it. Okay, we should see the exact same result as before. And we do, perfect. So our refactor worked, and now, let's see, idx +1, so we can switch back to a dynamic value. Now we just need to change this correctly based on our number of cycles. So let's see. This is going to be idx times canvas width divided by cycles, I think. And then this should be idx +1 times canvas width divided by cycles. In other words, the points that we're interested in have to do with canvas width and they have to do with cycles, right? So over here, we want to get a value of 0. And so we do that by saying, well, by multiplying by 0, right? idx is 0 in this case. So it gives us that idx +1, so it's like 1 times the canvas width divided by 1, which is just canvas width. But let's say cycles equals 2, and when we're right here, we want to get 0 for the left, which we already know. Over here, we're going to do canvas width divided by cycles, canvas width, which means canvas width divided by 2, which gives us the right result. So I think this is going to work. Let's run it. It worked. Cool. All right, we made an art, you guys. Yeah. Okay. I think it still doesn't look like much, so let's start to tweak some things and we'll see what we can learn. I think the waveforms are too tall because this is too spiky. So let's decrease the wave amplitude. And I think eventually we do want this pretty jagged. I think probably our problem though is that there's not enough scale to our piece yet. Like there's not enough going on to make it really like make sense. So let's basically like up the number of waves quite a bit. So now there's like quite a bit more going on. We can really like pack them down next to each other, which I think looks kind of cool. And it starts to form this kind of moire pattern, which I think is cool. Where like it's sort of an optical illusion, right? It like tricks your eyes. I like that. Could we go even more? Now we're off the screen. And I think we could even get away with like... Oh, that should be 0.75, whoops. Oh, that does... I mean, look at that. That's kind of sweet. It's not what we were going for, but you get this like cool, crazy aliasing going on. You start to like really pack the waves in there. Yeah, look at that. Like it turns into almost like a knit pattern, maybe like a sort of textile pattern. Yeah. If you're watching this on a small screen especially, it probably like forms this very strong kind of arc to it, which I think is interesting. There is aliasing going on up here, like on these. It's most noticeable on the very slowest wave. You can see how there's kind of this fuzziness going on. And really that's just because like we're working in pixels. As soon as we send this to a laser cutter, that aliasing is not going to exist. But yes, I think this is kind of turning into what I had imagined. I think this is pretty cool. Let's try going like simple to complex to simple and see if that's interesting. So let's see, the way that we might do that. It's gonna be up here. So we want to say cycles equals, and let's do a quick refactor. All right, so that's the same. But then let's see. We would say, is the index greater than or equal to num waves divided by 2? And if it is, then we're gonna say, what is it? I'm not sure. Then it's 1. Otherwise, it's idx plus 1. So this is not what we wanted, but let's see. It should really be num waves minus idx. Yeah, I think that's it. We might be off by 1, but no, I think we got it right. Because look, that ends in the correct number. And you know what? We can reformat this. I've seen it written like this before. This ternary operator. What's this complaining about? Misleading line break. How does it want me to write it? Like this? I don't know. We can do that though. No, I think this should be on the next line. Let's sometimes the right thing to do is to just write a good old-fashioned if statement. Yeah, look at that. What a fine looking if statement. Gonna space that out for clarity. Cool. And we should be able to decrease this quite a bit, and it'll be obvious that it's still working. Yes, it is, because these, like, this second wave and this fourth wave are identical to each other, and you can see the first and fifth are. So if we go crazy, boom, we get this result. I like it. Okay. It'd be cool if we centered the piece, I think. So let's see, what's the math for that? We need to derive this based on some other things. So we know that if we take this times this, that'll give us like the used up canvas area. And then we average that. Or, yeah, basically we take the average of that. Okay, so that should be, let's see, num waves times wave distance. And that should be, that gives us that. And then we need the canvas height in centimeters. And then we want to divide the entire thing by 2. I think that's what we want. That is not what we want. Let's see. So this is the okay, so let's see. This is the used up canvas area, which is, you know, like here. Then we have the total canvas area. Really we need to subtract this from this and then take the average of that. So height minus that stuff, and then divide all of that by 2. Yes, that's what we want. Cool. And so now this is nice because we can like change the number of waves and everything still fits awesome. And we can start to bump this up even. Be like, yeah, we're gonna go even busier, 70 waves. Cool. I'm thinking now about how we could totally sub out different waves for each other. So what if we do like, maybe that's a pretty boring refactor. We get the very same result. But then instead of that, we could be like, draw a sawtooth wave. And the way that we draw a sawtooth wave, let's copy paste that. We want to keep this. This should maybe become constant. But this is really okay, let's do this here. This is gonna be I'll do number of cycles equals 2. So start there, go up, click, and then down. I'm gonna have to turn off the whatever it's called, this thing. That's what it should look like. So there's a point here, here, and here. And these two are supposed to be exactly aligned with each other, like that. So let's see. we'll go, so at 0, this should be CUI minus amplitude pixels. And then we're gonna tween 100%. Yeah. Which means that our tween is not actually helping at this point. At least for sawtooth waves, it's not. So we can just say min x, max x, max x. And let's see, this should be CY plus amplitude. Wait, hold on. If I color code this, here's our start thing. But that's also a start thing. So there should only be 2. Yeah, there should only be 2 points inside of this loop. Yeah, check that out. Okay, so let's just remove that. UI plus amplitude x, and so then this final vertex should be CY minus amplitude px. Save that, run it. Oh yeah, that looks kind of sweet. Now let's see, I think we're going the opposite direction from what we intended. Yeah, there we go. This should be a plus. Okay. Up. And then down, yeah. Whoa. That creates a very different looking, like you still get that moire sort of effect where you've got this like ellipse going on. But the jaggedness inside is kind of cool. So now we can really quickly toggle between them. Like this is, it's still pointy lines, right? But it's quite a bit softer compared to this. Yeah, that's cool. I could imagine like a whole, what's it called? You know, like a whole series of 4 panels with like the 4 basic analog waveforms. That'd be pretty cool. You got like sine, triangle, sawtooth, square. Okay, I want to try something else though. I think that'll be fun. So let's do this. I'm going to hit duplicate. If we run it, boom, we get the same result. But I am going to, we might need that actually. I'm going to scrap all of this. I'll bet we'll need tween too, you never know. Okay, so we now have an 8 HP URAC panel. Again, that's this, but twice the width is what we're looking at. But now let's try something else. So we can head back over to Excalidra. Maybe I'll put this down below here. We'll give ourselves some room. I thought it was interesting how with our previous design, like we had to go to like really high iterations to make the scale of this look interesting. So it's kind of cool. I think with randomness, you don't necessarily have to go as high, but we'll find out. Okay, so what should we do with this next one. I want to get across this idea of like your work, like when you're doing modular synthesizers, you're working with waveforms. It's orderly in that way, but there's a fair amount of like randomness and chaos, and that's like what makes it organic. And so I want to be able to express like random waveforms or random, I don't know, random things about them. We could do like random phases of waves. Maybe that would be cool. Waves going in random directions. You know, you can probably imagine like there's a wave right here, but then there's a wave that's like doing that kind of a thing that like goes all the way off the page. We have to decide whether we want it to be like, whether the piece should feel soft or like harder, you know, because different waveforms are gonna evoke that. Different phase offsets like that, you know, effectively that means you're taking your wave and you're moving left to right. Let's save this for a second. I want to come back to here. And one thing that we could do is like, we could basically render the entire piece a second time over here, and then render it a third time over here. They're both off the canvas, but then what you can start to do is you can shift phases however you want. And like that stuff that's off the frame doesn't matter, but you end up with more chaos in the middle. You could try that. So we'll come back over to here. Right, here's our original piece. Yeah, let's say with random phases. Let's see, how does our code work? So here's where we iterate, right? We say draw wave, UI and cycles. So what if we do all of that work in draw wave? Or we could even say like phase equals random. And this is going to be a random percentage times what, the canvas width? Probably canvas width. Yeah, I think it's the full canvas width because we're going to create an entire copy to the left and to the right. Put that in right there. I want this to replicate through to each of these helper functions. And I mean, we're showing sawtooth waves for now, so let's just implement it for that first. And really, phase isn't like, we're really just saying like offset X. it's not really, like, we're not talking phase in terms of like, in terms of the period, how much we should phase. It's pixels at this point. Just put that there. So, let's see. We need to shift everything by that phase. You may have noticed that I like using parentheses on everything. I prefer making all of that math as explicit as possible. Okay, so when I run this, we're going to end up with a whole bunch of holes in the left side of our image. And that's because we haven't actually duplicated the waves over there yet, but we will. Shoot, that actually looks kind of awesome. Interesting. Yeah, that's kind of cool. I think we should, let's finish the piece the way that we had planned on it, but that's pretty cool. This is making me realize that we don't need to render another copy to the right, we just need to render a copy to the left. Let's see, so here's our right copy. No, I really want all of this to be part of the same shape, don't I? So let's see if we can pull that off. And all we really have to do, let's see, we need to say plus offset x minus canvas width. And then this picks up right where this left off, because the loop, like this final vertex is what finishes off the loop. I think that's it. Yeah. Cool. So now one thing that we could do, like we could start kind of scaling that down. If we do 0, then like there's no change at all, right? But we could say like you're only allowed to offset a little bit, 10%. So there's like just a little bit of chaos that breaks up that moire pattern. The problem with that, I think, is that like in the middle here, it just looks like waves. You can't tell that it's going from like less complex to more complex because we've broken up all those lines. Whereas like forming that really strong pattern around it makes that clear. So that's interesting. I feel like our experiment didn't really work. One thing that we could do though is called a drunken walk, and that's where you start from a number and then you just sort of like randomly move around it, but you're always starting from the number before, and so you're not just bouncing around quite so much. You're sort of like gradually shifting, and that'll create more continuity. So let's try that. And I think we should start it at 0. Oh, whoops. So this needs to be a let. And then we'll say offset x is equal to offset x plus some random value. We pick You know, I can collapse some of this, can't I? And in fact, this will read better. So start from your previous offset X, and then add some amount of randomness. Let's see, we need to bound this a little bit though. We should be allowed to go from 0 all the way up to canvas width. So I think there's a function called clamp. No, maybe not. There's min and max, so we can implement it that way. Min, max, number. This is maybe a keyword, JavaScript. And let's see, this is going to be min and max are functions as well. So we need to say return the min of, oh no, it's the max of min bound and number. But then we need to wrap that in the min of max bound and number. So that is clamp. That way, we're not allowed to go below 0, we're not allowed to go above canvas width. So actually, that means if we want to have like an even-looking drunken walk, we should start this as canvas width times 0.5. And so then we'll pick some amount of shift, add it to the old offset, and then we'll clamp the whole thing. So that should be between 0 and canvas width. Yeah. Oh, whoops. Is this working? Let's see. Yeah, it is working a little bit. Now, I'm not seeing like disruptions over here. I wonder what that means. I wonder if like I think we might need to log some stuff here. New offset X. Hey, look at that. So it like ended up on a value and then just stopped. Okay, so we increase all the time. Oh, and this number can never be negative, so that's our problem. Okay, so this now needs to become do something like that. Divided that by 2. But now, yeah, okay, now we've got quite a bit more chaos. So we start here, go down, come up, go down, go down, go down, go down. Go quite a bit down. Here's as low as we can, I guess. We kind of stay in those single-digit numbers. Cool. I think I sort of like this. This looks kind of cool. I just thought of another idea though, and that's that what if we actually, instead of linearly increasing the number of cycles, what if we exponentially do it by the powers of 2? That might look really cool. So now I want to try that. By the way, this is one of those really fun things about generative art, is like you start putting ideas down and then making changes. I don't know, it's a very just iterative process. If I had like painted this or drawn this, you know, by hand, then I would not be very interested in trying another one probably with this scale. But with code, I totally can. So I like that. Okay, so we want to go like exponential. Let's see, the number of cycles. And let's maybe get rid of this like going up and going down thing. Oh, JavaScript doesn't have a power function. Hopefully p5 does. Let's see. Or has a math.pow, I think. We want to go idx to the power. No, we want to go like 2 to the power of idx. Ow. Yeah, 3 to the power of 5. So we want pow 2 comma idx. Okay, so 2 to the power of 0 is 1. So we get 1 cycle, that's what we want. And 1, 2, 4, 8, etc. We've thrown enough complexity at our computer now that it's having a hard time rendering this. This page is slowing down Firefox. Oh dear. Okay, let's refresh this. Oh, I threw away our work. Okay, so cycles equals power of, what was it? No, 2 to the power of idx. Okay, and let's do like a low number first. Okay, so yeah, I guess we should have seen that coming, right? Like it becomes like our number gets so big so quickly that it just turns into a big bar. I guess we could make it work if we rotated the whole canvas, you know, and like did it that direction. I don't think it would really read though. Like, I don't think you would look at it and be like, oh, cool, it's the powers of 2. I feel like our previous like story of, you know, whoops, let's make it real big. You know, the harmonic series basically go up and go back down. Like that's a better musical story to begin with, and like I don't know, it just looks better because we don't get into like super crazy huge numbers of cycles. Oops. Okay, cool. So let's save that. I want to... Oh, whoops. I lost some of my other changes when the tab crashed. So I'll make this here. And then we need to subtract it. Save that. There we go. Yeah, I think that's looking cool. All right, so we've got our two pieces. Let's like duplicate this over here. We can open up both side by side. This one's deterministic. We'll get the same result every time. And this one's more random. Every time we run this, it'll be a little bit different. I think the shape of our randomness is very uniform though, so it'll look, you know, if you squint at it, it's going to look the same every time you refresh. But we've got our two different designs. And I think this is a good place to kind of end for the day. So if you're tuning in live, thanks for joining. And if you're watching this in the future on YouTube, thanks for checking it out. Like I mentioned before, P5 is a really awesome way to get into generative art and to get into code. It's really fun to be able to like make a quick change and then instantly see it being applied on the canvas. Very satisfying, gratifying, it's just cool. Yeah, this was a good sesh. So, yeah, we'll wrap that up. Let's see, for next week, I think we're ready to do Screeps. So, get ready to check that out. You can buy the game on Steam if you want. It's called Screeps World. And let's see, Screeps has a Discord server that I think I'll probably jump in there and market this a little bit as well. Be like, hey, we're gonna stream. Try to gather up some folks that way. But yeah, thanks for tuning in. And what did I say last time? Stay creative. Yeah, stay creative. This is Code Gets Creative. Thanks again. See ya.